we continue our event by providing to you an overview of the Marvel project. First of all, I introduce Professor Sotiris Ioannidis. He is, first of all, the coordinator of Marvel. He's also currently associate professor at the School of Electrical and Computer Engineering of the Technical University of Crete. He's also director of the Microprocessor and Hardware Laboratory.
Okay, thank you for the kind introduction. Also, the previous presentation, I mean, it was great because it served as motivation for the Marvel project. So I actually don't need to do much about convincing you that this is important. So again, my name is Sotiris Ioannidis. I'm the coordinator of Marvel. And I'll be presenting an overview of the project in the next 10 or 15 minutes. So let me just start by saying that Marvel is a research project. So the technologies that we invent and build in this project are hopefully going to be adopted in the coming years by industry and are going to help the lives of citizens in smart cities. It's a project that has 17 partners, and I'll talk about the consortium in a bit. It's a fairly large budget of 6 million, and we're currently past the one-third mark of the project. So it's a 3-year project, and we just ended our first year. So we still have a couple of years to refine our technologies and improve what we deliver from the work that we've been doing. So in terms of consortium, we're lucky enough to have a quite diverse type of consortium. So it's comprised by research centers, which tend to do more applied research. We have a number of universities, which are more pie-in-the-sky research, but we also have big companies and SMEs that build the tools that are necessary for Marvel. And of course, the smart cities that provide the use cases, the pilots, and the actual test beds to test all our technologies. The other interesting thing is that we have a fairly diverse composition in terms of countries. And this is quite interesting because each one of us brings their own experiences about where they live and what they would like to see. So this is a nice added bonus that we have. So I have to do the mandatory definition of what a smart city is. So one of the definitions that you find out there is that a smart city is an innovative city that uses ICT and other means to improve quality of life, efficiency of urban operations and services, and competitiveness, while ensuring that it meets the needs of present and future generations with respect to economic, social, and environmental aspects. So again, the mandatory definition. But what we need to keep from this is that smart cities are actually quite complex and sophisticated systems. So, and as such, and as we actually live in them, they attract a lot of attention, of course, by the state and policymakers and whatnot, but also from various industries that want to provide solutions for the citizens. And of course, scientists that want to build new solutions that industry is going to adopt and sell to their customers, mainly the cities. So it's a quite interesting environment to work in and experiment and do interesting things. Now, of course, when we started this, we had a motivation in our head, and the motivation was that what we call cities have become data engines. So what does it really mean? It means that the city produces huge amounts of data. And the way that this is done is primarily the IoT sensors and devices that are deployed throughout the city. And these devices, the most obvious example is cameras. But it's not just cameras, it's audio sensors, it's temperature sensors, humidity, and so on and so forth. So these sensors collect data 24/7, and we're talking about large quantities of data that attract the interest of scientists, obviously. Now, there are, Of course, a number of challenges when we have to deal with this sort of data in terms of variety and size, but also real timeness of generation. And that has to do with how are you able to extract valuable knowledge from this data and actionable knowledge from this data. And of course, tie this in to commercial benefits for whoever uses this data. So this leads us to say that what we actually need is a better way to make predictions, and the way to make better predictions is to make better analyses. To accomplish, of course, this, traditional methods may not typically work, again, because the data is real time and it's large quantities and high throughput. So we need to come up with new methodologies, new techniques, new tools to extract all this valuable knowledge and all this commercial value out of the data. So the question that remains to be answered is, how do we actually do this? And this has to do with addressing the problem of what we call extreme scale data analytics. So after sort of motivating this problem, what is the vision that we have in terms of Marvel, and how do we use Marvel in order to drive this EU data economy? So this economy that is rising, that bases the value on the data that one can collect and analyze. So first of all, our vision is to address and solve the challenges of the big data value chains. So this is finding practical ways of dealing with big data from end to end. So it's a value chain. Data exists at every level and is processed at every level. Secondly, again, because we're scientists, what we're interested in is open science and open data. So whatever we do, we want to be able to open it to others and have other smart people use these tools and this data to create new solutions. So what we want to do in Marvel is create this data corpus that is going to drive innovation. The other point is that, of course, we want to invest in research and innovation. Again, we're scientists. We want to create new knowledge. And finally, throughout this process, we want to engage the citizens. So we want to make tools available to citizens and want to make these technologies available to citizens and get their feedback in all this, because they are the ultimate user of these technologies. Now, having said that, I have a picture here that I think captures the whole essence of Marvel. If there's one image that you need to remember, is probably this one. It is a bit complex, but we try to visualize it in a way that makes it a bit simpler. I think the point to keep from here is that we have a number of things that will come into Marvel that we'll use as baselines. So the data capturing part, technologies about AI and learning, the computation that we can do from the edge all the way to the cloud, and the benchmarks that we set in order to evaluate the results that we come up with. And these benchmarks can be industry benchmarks or societal benchmarks. So how do we impact people's lives? And after Marvel, we want to be able to have better decision making, for example, have this data corpus that is going to be out there for others to experiment, improve the quality of life of citizens in terms of public safety, well-being, and so on and so forth. So keep this picture in your head, because I think it really captures the essence of Marvel. So in one sentence again, because we need to summarize what we've said so far, our mission is to collect, analyze, and data mine multimodal data. And this data comes from data streams in a smart city. And these data streams, after we analyze them, help decision makers to improve the quality of life of citizens. All this we want to be doing without violating any ethical limitations or any privacy limitations that the citizens have. So this is the mission that we're trying to accomplish with Marvel in one sentence. Going a bit into the more technical things, although I'm not going to be going too much into this because we have a presentation after mine that goes into the details. Just remember that we're basing all this in a number of pillars that comprise the Marvel framework, and that has to do with real-time and heterogeneous big data that come from smart cities, the edge to fog to cloud computation, the AI technologies, and finally the benchmarking pillar that we have in order to evaluate all the technologies that we build within Marvel. I'm jumping now very, very briefly to the experiments that we're going to be running. And again, there are going to be presentations about this later on. So this is just a highlight of what we're planning. So we have three experiments. One is in Trento about city monitoring. And again, details are going to come in later. We have Malta in the experiment that has to do with road traffic management. And we also have another, I'm going to call it a micropilot in the city of Novi Sad that tests baseline technologies using data collected from drones. And again, there's going to be more details about this coming in later. I have this picture here just as a teaser, just to show everyone how complex this solution is evolving to be. The presentation after mine is going to be going into details about all these components, but this is visually capturing the complexity. And yes, it's a complex problem, it's a difficult problem, but it's actually a very interesting problem. And with this, I'd like to close here and thank you for attending our Info Day. We have a number of contacts, our website obviously, but also LinkedIn and Twitter. So please link up with us and follow us and send us questions or any other things you may think of. We love linking up with people and we love engaging others into the project.